All right, so a lot of work so far. Let's not lose sight of the original goal, right? The original goal was to solve the following system. And I wish I could tell you that we were close, but we're not. So that's kind of why I took a break in the middle of a problem. So does it make sense that normally if you solve a system, you figure out the value for x and the value for y, correct? Now, where do we leave off in this problem? Well, we left off in this problem. Well, remember, we had just added, and we got 0, right, because the x is canceled. And it was plus the following. But does it make sense to you that this is not y? Right? This is, in fact, this is a second order differential equation, right? It's a linear, it's non-homogeneous, but it is a second order differential equation is what you have at this point. So you need to solve for that in order to solve for y. So let's review that really quickly, that y of t, now this is back when we were using the method for undetermined coefficients. And if you need to revisit that, that's something that you'll have to do. But I'm actually going to, just as a preliminary, I'm going to go ahead and walk through this method of undetermined coefficients for you one more time. But if you recall that y is just equal to the particular solution, right? It's a particular solution to non-homogeneous plus the general solution to the homogeneous. All right. So we have our work cut out for us. Let's start with the general solution to the homogeneous, and that's actually not that bad. So in other words, we'll start off with this part right here. So in that case, what we would do is we would take our y double prime plus 4y prime minus 5y, and we would move from here to auxiliary form. Right? So in that case, we would have, let's say, a being equal to 1, b is equal to 4, and c is equal to negative 5, right? So the auxiliary form would look like this: r squared plus 4r minus 5. Now remember, this is for the general solution to a homogeneous. So we set it equal to 0, just like we did in the previous sections. Now, hopefully this factors. If it did not, we would have to just simply use our, we would have to use our quadratic formula. But let's go ahead and go ahead and set it up. This one actually does factor r plus 5, r minus 1. And now let's look at our roots, right? Are we getting double roots, single roots? And in this case, we end up with roots equals r is equal to negative 5, and our root r is equal to 1. So that's actually nice, because sometimes with the homogeneous solutions, depending on the types of roots that you get, right? If they're complex roots, imaginary numbers, we have to use a different setup. If they're double roots, remember there's a different setup. So just remember that right here, because we get two real distinct roots, means that we basically, at this stage, we can just plug in the negative 5 for one of the r sub 1s, and we can plug in the 1 for the r sub 2. So we end up with c sub 1 e to the negative 5 t plus c sub 2 e to the 1 t, or just t. Now, okay, so now we know at this stage, we know what goes here. But now, in order to deal with this 14 minus 30t, we have to use that method for undetermined coefficients that we studied prior. So let me go ahead and start working on that part. So we're going to take a look at that non-homogeneous solution, 14 minus 30t. And if you recall, the question is, what form are we dealing with, right? What is the form of the answer? Well, 14 minus 30t, that's just linear. So we're going to use the at plus b form. All right? So in other words, what we have is y being equal to at plus b. Y prime would be equal to a. And of course, y double prime would equal 0. Now, what do we do with this information? Well, that information is what goes into our y double prime plus 4y prime minus 5y, if you recall. So we're simply plugging in here, here, and here. All right, so let's go ahead and do that right now. So that's going to be 0 plus 4a minus 5 times at plus b, right? And of course, we need to find the a and the b such that it is equal to 14 minus 30t. All right, so what I'm going to do right now is I'm going to go ahead and distribute. And then anything with a t attached to it needs to be isolated by itself, and anything with just the coefficients or the constants a and b can be isolated, clustered by itself. So this would be, we got negative 5 at, and that's going to be plus, and then we got our 4a minus 5b here. And again, that's supposed to all equal 14 minus 30t. Okay, so let's go ahead and start with the a. So since this is the only term that has a t attached to it, I know that negative 5 times a has to equal negative 30, right? So in other words, negative 5a t has to equal negative 30t. And that's only going to happen if negative 5a is equal to negative 30. So in other words, a would have to equal positive 6. Okay. And now, let's go ahead and look at the second part. So now we would have the 4a minus the 5b, and I do know what a is in this case, but I know that that's going to have to equal 14. So with a equal to 6, that's 24 minus 5b has to equal 14. In other words, you can solve for b, and we get a value of b equal to, what do we got, 2. So b is equal to 2. Okay. So the solution for y is going to be the particular solution to the non-homogeneous plus the general solution to the homogeneous. Now, I already have the general solution to the homogeneous form. And then all I need to do is plug 6 in for a and 2 in for b, and I'll have the particular solution to the non-homogeneous as well. So all of that worked so that I finally know what y is. Y of t is going to be equal to the following. So y of t is going to be equal to the particular solution, so that's 6t plus 2 plus, the particular solution plus the general solution. So that's c sub 1 e to the negative 5t plus c sub 2 e to the power of t. Okay, so now I understand that that is quite a lot of work, and we are still not done, because what do you normally do when you, at this stage, we have solved for y, right? And when I gave that quick review for elimination method, normally you solve for y, and then you take y and plug it in, correct? Right, that's normally what we do. So let me go back. Let me go back to this, this equation. Right, because what I'm going to do is I'm going to write this equation that I'm circling right now, and I'm going to solve it for x. So ready? So let's go ahead and let me go ahead and write that. So if I have, start off with, I got y prime of t was equal to 4x of t minus 7y of t plus 10t, correct? Yes. Okay. So this is the original second equation in our system. And now, remember what you, again, just to parallel this to the methods, you know, normally you, after you have y, you plug it in, right? You solve, you take that and then you plug it in for y in the other equation so that you can figure out what x is. So what I'm going to do right now is I'm going to take this, the second equation of that, and I'm going to solve for x. Okay, ready? So let's go ahead and do that. So we're going to bring our 4x over here, and we're going to bring our y over here, y prime over here. And we should end up with, well, let's see here. We would have negative 4x of t, and that's going to be equal to negative y prime of t minus 7y of t plus 10t. And I'm going to go ahead and divide, because I'm trying to solve for x of t. I'm going to divide by negative 4, divide by negative 4, divide by negative 4, divide by negative 4. Okay, so we finally get x of t is equal to, well, that's going to be negative 1 over negative 4. That's 1/4 of y prime of t plus 7/4 y of t. And we got 10 over negative 4, so that's minus 5/2 of t. Okay, so if I can have your eyes for just a second, this is all that's required for you to finish this up. So do you agree with me that after all of that work, that's the upfront work, you're almost at your answer, okay? But that's just y. Now you have to sub that in to find x. Okay, so to do that, what would be required? So if you think about, at this stage you have x, so we can take this entirety of this y, we can sub it in here. But then you have to ask, well, what would you sub in for y prime? Well, you would need the derivative of y. And then you would sub in, and you would be done. You would have to, obviously, you'd have to simplify where it can be simplified. But let's go ahead and do that right now. So let me go ahead and I'm going to be taking this and distributing it in here. Then I'm going to be taking the derivative of this and plugging it in here. Okay, so let me do that. So that means x of t is equal to, ready? So this is 1/4. Now I'm not going to take the time to show you how to take a derivative of y. That's fairly easy to do. You're taking the derivative with respect to t, obviously. So let's just go down the line. So that's going to be derivative of 6t. So that's just going to be 6. And then we have plus, well, the derivative of, actually it's going to end up being minus, actually. So the derivative of c sub 1 e to the negative 5t that's going to be negative 5 c sub 1 e to the negative 5t. And of course, the derivative of e to the t is just e to the t, so it's plus c sub 2 e to the t. All right, that's going to be plus 7, and I'm going to actually do all this on the next next line. So that's going to be plus 7/4. Now there's no work to be done here. All I have to do is plug in what I originally got for y. So that's 6t plus 2 plus c sub 1 e to the negative 5t plus c sub 2 e to the positive t. And then the only thing left in that was minus 5/2 of t. Now, all I would do at this point is just drop those brackets and start to simplify everything. All right, so we would just simplify everything out. And this is what you would end up getting. So if you just drop the brackets and combine like terms, you would end up getting the following. So you would have 1/2 c sub 1 e to the negative 5t plus 2 c sub 2 e to the t plus 8t plus 5. All right, so what I have boxed in at the top and at the bottom is x and y. So you can see that it is, if you want to solve a system of linear differential equations, right? That's what you just did. They are quite, it is quite involving. And we're gonna go ahead and call it quits for this video. When I come back, I'm gonna try to give you a procedure that can make this a little bit easier, not a whole lot easier, but a little bit easier. It just involves because that is quite demanding. And so I'm just gonna, at this stage, I'm just gonna do my best in the next video to try to show you just a way of finding a general solution for a system with a little bit more procedural work. So you have step 1, step 2, step 3, that type of work. I just, again, really quickly, just so you understand, this here, what you have, this is a general solution to a system of differential equations, right? So this is the solution. What I just had there is the solution to that system. All right. I hope that was, I know that was painful, but hopefully you were able to follow me through that. I will see you in the next video.